Now sometimes in the exam your rate question might look something like this. So you can see at the top we've got the rate equation, and underneath we've got a partially completed results table. And basically the point of the question is to work out the missing values. So there are 4 missing values in this case. Just explain what the headings are. So obviously we've got 5 experiments, and they've been carried out with different initial concentrations of A and different initial concentrations of B, and the initial rate has been measured. Now I've not bothered with the units here just to save some space, but obviously we'd have moles per decimeter cube for the concentrations and moles per decimeter cube per second for the rate. So in this video I'm going to look at how we can work out these numbers by using the rate equation. If you already think you know what to do, obviously pause the video, work out the missing numbers, and then play on and listen to what I get. If not, then just keep listening and we'll go through it together. So the first thing we need to do is calculate K. So you can see I've rearranged the rate equation and made K the subject, and all I'm going to do is substitute in the values from experiment 1 because we have all 3 of those values, and we'll work out K. So now we know K, we can work out the first missing value, which is the initial rate for experiment 2. So K doesn't change, the temperature is consistent in these series of experiments. So K is 15, the initial concentration of A is 0.04, and the initial concentration of B is also 0.04, but we've got to remember to square that. So that gave me an answer of 9.6 times 10 to the minus 4. For the next one, you can see I've rearranged the equation, so we've got the initial concentration of A equal to the rate divided by the rate constant multiplied by the initial concentration of B squared. And that's come out, you can see, at 0.01. The next one, so the missing initial rate for experiment 4, well, it's going to be exactly the same as the way we did this one here for experiment 2. You can see I've got 8.1 times 10 to the negative 4. And to work out the final one, you can see I've rearranged it so we've got the initial concentration of B squared. I've kept the squared term in, just remember we need to square root at the very end. So that rearranges to B squared concentration equals rate over K times the initial concentration of A. So you can see I've got the concentration of B squared coming out at 0.0012. So we just need to square root that. You can see there's my calculator value, and to keep the numbers consistent, you can see I've expressed it at 0.035.